Okay, so in the last lesson we were talking about where lines cross or if they cross. We're going to eventually kind of do the same thing with planes. And just like lines, they might cross and they might not cross. They could cross in a point. They could cross a lot of different ways. I think there's 9 ways that planes could cross. But for now, we're just going to learn some algebra and how to solve these. You could have had a question like this way back in grade 10 when you were doing substitution and elimination, but usually you only ever had to solve for 2 variables. So most of your questions only ever had an x and a y. So if you wanted to do this one with elimination, what you would do is you would eliminate a variable from these 2 equations, from any 2, but I would just take the top 2 here. So maybe I would get rid of the x's. So maybe I would multiply the first one by 2 and then subtract. So I would have something then just with y's and z's in it. Then what you would have to do is do the same thing, but on 2 different equations. So maybe you could use equations 1 and 3. So you could times this one by 3 and then add them, and again the x's would disappear and you'd have another equation with y's and z's. Then what you could do is line up your 2 equations with y's and z's and solve like you did in grade 10 for y and z, and then do some back substitution and find out what x is. So you could do the question that way. Matrices, I feel that you should see them, and it makes it a little bit easier anyways. So I'm going to show you what a matrix is because I really think, like I said, that you're going to see it next year anyways, and you should know how to do them. Okay, basically you drop off the letters. So we're going to have 1, -3, -2, and you put this on the other side. Now, this isn't true Cartesian form, right? Because usually there's a +9 over here, but what you're going to do is move the constant to the other side. And you know from grade 10, same thing, standard form, half the time it has the constant over here and the other half of the time it has the constant on the other side of the equal sign. So that's not that unusual. Okay, so we have 1, -3, -2, -9. And then we have 2, -5, 1, 3, and -3, 6, 2, and 8. So that's basically what a matrix is. Now, what we're going to aim for is we want just to have a 1 there, there, and there, and then some answers here. And that's kind of just like what elimination does. It eventually tells you what x is and what y is. So we want the 1 here, so we're going to have 1 and hopefully a number. So that would be like 1x equals 10, or whatever number happens to be over there. We would hope all of these other entries are 0. We would hope there's a 1 there, and that would be 1y equals whatever number happens to be there. And right here we would want a 1, and that would tell you the answer for z. So that's kind of what you're aiming for. So I think the easiest thing is just to solve one of them. And yeah, so here's the same matrix as what I just wrote out, I believe. Yeah. So this is the same question. So we're just going to solve this system using a matrix. Keep in mind, you could do a bunch of elimination, but it's easier to do it as a matrix, even though a matrix is essentially a bunch of elimination in your head. Okay, so here we go. These questions get really long. I like this 1 right here. So you're always aiming for a bunch of 1s right there. I like that 1 there. If there was a 1 down here, you could flip equations. So you could move this equation up there. There are certain rules, so you can interchange rows. But I like the first row just like it is. What you always want to do is try to get a 0 in this entry and in this entry. So those are your first things that you're going to aim for. You could try to get 0s over here, but the thing is, if you don't do these first, you might mess up the 0 you get here. You'll see what I mean after you start doing them. So if I really want this to be 0, what I'm going to do is I'm going to take, I'm going to do 2 times row 1. So I'm going to go 2 times row 1. You're supposed to write out what you do. And you know me, half the time I don't. So that's 2 times R1. So 2 times row 1. And I'm going to subtract row 2. So I'm going to do 2 times this row and minus this row, and that will give me a 0 right there. By the way, you could have done this row minus 2 times that row. I don't care which way you subtract, as long as you get a 0 in this position. So if I do 2 times the first row, that's going to be 2 minus that 2 is going to give me a 0. 2 times row 1 is going to be, it's a lot of mental arithmetic in your head here. So 2 times this is going to be -6, minus 5 is +5. Which is -1. 2 times this one is going to be -4, minus 1 is -5. And 2 times this one is negative 18, minus 3 is negative 21. Okay, now I'm going to do the same thing, but this time I'm going to do 3 times this row and add it to this row. So I'm going to do 3 times row 1 plus row 3. So 3 times this row plus this row is 0. That's good. That's what I was aiming for. 3 times this one is negative 9 plus 6 is negative 3. 3 times this one is negative 6 plus 2 is negative 4. And 3 times this one is negative 27 plus this one is negative 19. So there's our new matrix. By the way, it's really just a bunch of elimination in your head because that's essentially what I did, right? I multiplied this, oops, I'll go back up here. I multiplied this by 2, so it was the same as this guy, and then I subtracted to eliminate the x's. It's basically elimination in your head. So now what we want to do is we want to clear out this one. So this is the next one right here that I'm aiming for. So I want this one right here to be a 0. So you want to clear out this bottom corner. And notice, so I got a couple of zeros in one matrix. You don't have to do a matrix for this one, then a matrix for this one. Do more than one if you can. So, oops, I should go back to blue. Okay. Okay, so I just rewrote out the matrix. And notice that I took my old row 2 and I multiplied it by a negative. So I did negative 1 times row 2. And when I say row 2, I mean you always refer to the one up here, not, you don't go back to the original one. So I just don't like all those negatives, plus I want a positive one there. So I just multiplied everything by a negative and it turned out those positive. Okay, so I'm going to aim to clear out this right here. So what I'm going to do is I'm going to multiply this guy by 3, which would give me a negative 3, and then I'm going to subtract. So I'm going to do 3 times row 2, 3 times row 2, and minus row 3. I mean, if you want to multiply this by negative 3 and then add them, that's fine too. I mean, it's just like elimination. We don't all do it exactly the same. Okay, so I'm going to do 3 times this one minus this one is still 0. See, I didn't mess up that 0 that I got there. So I'm going to do 3 times this one is going to be negative 3 minus negative 3 is 0. That's good. I'm going to do 3 times this one, which is negative 15 minus negative 4 is negative 11. And 3 times this one is negative 63 minus negative 19 is plus 19, which is 44. Okay. At this point, you should see something really nice that I could do with the third row. I kind of wanted blue there. So 1, negative 3, I'm not going to do a lot here. 0, 1, 5, 21. And you can probably guess I'm going to divide this row by negative 11. And that will give me a negative 4 right there. So I did, okay, technically you don't divide a row by anything, so really what I did is I multiplied it by a negative 1/11. So I did negative 1/11 times row 3, which really means I divided row 3 by negative 11. Because really your row operations, you can multiply by something. You don't really divide by anything, you multiply by something. Just like here, I multiplied this by a negative, I multiplied this one by 3. So you multiply by something. Okay. You can actually stop there. This is not fully row reduced. Really, to have it fully row reduced, you want to clear out these as well. So after you clear out the bottom corner, I'm going to clear out the upper corner. So I've circled here what I want to clear out. I'm going to clear out this guy. Notice this is actually an answer for z, by the way. This really means no x's plus no y's plus 1z equals negative 4. This row tells you that z is negative 4. So you're 1/3 of the way to there to your answer. I'm actually going to clear out this one next. So what I'm going to do is multiply this row by 5, and I'm going to do row 2. So I'm going to do row 2, oops, I should put that up one. So I'm going to do row 2 minus 5 times row 3. So row 2 minus 5 times row 3 is still 0. That's good. Row 2 minus 5 times row 3 is still 1. That's good because I didn't really want to mess that one up. This row minus 5 times this row is 0. That's good. And this row, which is 21, minus 5 times this one is minus 20, is actually 1. So look, there's my answer for y. So this one said z is negative 4. This one says y is 1. And if I could get these two positions to be 0, then that will tell me my answer for x. For right now, I'm actually just going to, actually, no, I'll do something. So I can't clear everything out at once. I can only clear one of them at a time. So I'm going to clear this one out right here. So I'm going to multiply this one by 3. And since the signs are different, I'm going to add them. So I'm going to do row 1 plus 3 times row 2. So row 1 plus 3 times row 2, that is still a 1. That's nice. This guy plus 3 times this guy is the 0 that I'm wanting. This guy, negative 2 plus 15, because I had to multiply this by 3, so negative 2 plus 15 is 13. And negative 9 plus 3 times 21 is 54. Oops. So I'm almost there. I can see my answer for z. I can see my answer for y. I need to see that answer for x. So what I want to do is really clear out this 13, and I'm going to use this one to do it. So if I could make this one a 13, then I could subtract them and the top 13 would be gone. So what I'm going to do is I'm going to do row 1 minus 13 times row 3. So row 1 minus 13 times that still keeps me with my 1. Sometimes it does get messed up, so then you'd have to, like, if this ended up being a 2, it's a bad example, but anyways, you'd be able to get it back to a 1. This minus 13 times this is going to keep that 0 there. This minus 13 times this is going to be a 0. And 54 minus 13 times negative. Sorry, I did notice I made a little mistake. That's actually a positive 4 right there. I just caught it because I was looking and I knew the answer. So this is actually a negative 44 right there. Let that be a warning. Sometimes you can do these many, many times. And it's just so easy to make a small error. So that's actually a positive 4. Okay, so when I do row 1 minus 13 times row 3, I actually get a 2. So this tells me x is 2, y is 1, and z is 4. So the solution is 2, 1, 4. Now in this note, we're kind of just learning how to solve matrices. You're not actually supposed to interpret the solution, but since it's sitting here, I'm going to tell you what this interpretation is. You have 3 planes. This is a plane, this is a plane, this is a plane. It's like 3 pieces of paper. The easiest way to look at this is the corner of a room. So it's like, here's one piece of paper, here's another piece of paper, and here's a third piece of paper. So, of course, these all hit at 90, which ours don't. But anyways, so I'm just thinking of a corner of a room. So this is like the floor here. So the blue is like the floor, and these are the 2 walls. The 3 corners of the room intersect at a point right there. Now, of course, like I'm saying, these all hit at 90. Our planes do not all hit at 90, but nonetheless, all of our planes do cross at a point. So this is an example of 3 planes, 3 pieces of paper, or I'm thinking of a floor and 2 walls, and they all intersect at a point. So our 3 planes, I wouldn't dare attempt to draw them, they actually cross at the point 2, 1, 1, 4. So that's what this means. Some of you are going to say, I would way sooner just do elimination a bunch of times. You say that only because you know elimination. When it gets right down to it, elimination isn't that fun. So you really should try to use a matrix. It's good to try something new. Okay, so there are a couple more examples on this page. I'm just going to do one because really you just need to try it yourself. So, and you won't necessarily do the same steps as what I do. So I'm going to walk you through myself doing one. You can do it on a piece of paper on your own, see if you get it. But remember, it's really just a bunch of elimination in your head. And what we're trying to do is solve for x, y, and z. So we want to see where these three planes cross. Now, of course, you can get weird answers, and you would get weird answers when the planes don't cross. So the examples we're kind of doing, they all cross at a nice point. But that, of course, is not always the case. So 1, 1, 2, this is an example where you got to move that -3 to the other side. 2, 3, 1, move the 5 to the other side, and 1, -4, 5, and move the 6 to the other side. Make sure you write it down properly. So I would like double check these 1, 1, 2, -3, etc., etc. Okay, so like I said, you can definitely interchange rows, but I actually really like the first row because it starts with a 1. So if this one started with a 5 right there, I might take this bottom row and move it up. Maybe that would be the first thing I would do. But I like having that 1 in the upper left-hand corner. So 1, 1, 2, -3. Okay, so think about what you're going to clear out. You pretty much always clear out these two guys first. So I'm going to do, you can do 2 times row 1 minus row 2, or you could do row 2 minus 2 times row 1. I'm going to do row 2 minus 2 times row 1. And then as far as these two go, the first and the third rows, they're actually really easy. You can just directly subtract them. So you can either do row 1 minus row 3 or row 3 minus row 1. Sometimes I look over here. Do I want to do -4 minus 1, or do I want to do 1 minus -4? And since I want a positive, I'm going to do the top row minus the bottom row. So I'm just going to go ahead and do that and put the answers in, and then you can try it yourself. Okay, so I just went ahead and filled in the answers for what I got. Now what you want to do is clear out this right here. So you always want to clear out the bottom corner. If you try to clear the top corner out first, you're going to mess things up. Like you're going to, you can get the zeros in the top corner, but then when you try to get the zeros in the bottom corner, you're probably going to mess up the zeros that you just found up here. So you have to do these first, so that, and then you can do these. Okay. So since I want this to be a 0, notice I didn't touch the first 2 rows. I'm going to multiply this guy by 5, and you can either subtract up or down. So I'll do row 3. So I'm going to do row 3 minus 5 times row 2. Again, in reality, when I do these on my own, I never write down what I did, but if you were going to do them for somebody else to follow, you really need to tell them what you're doing. Otherwise, they'd never be able to check your work. Okay. By the way, it is handy to have a calculator. I mean, obviously, when you multiply by 5 here, that's not hard, but sometimes it is a little tricky. That one's not hard, but just when you're doing the mental math, it's easier to have a calculator sitting there. At this stage, we could easily divide this by 12. This is when you kind of go, oh, and by the way, I'm not really dividing by 12. I'm actually multiplying by 1/12. Because you know 12 is not going to go into that nicely, so right away you know you're going to have a fractional answer for z. But we're going to do it anyways. Again. Okay, so like I said, I divided the third row here by 12, or I multiplied by 1/12, and you get -52 over 12, which reduces to -13 over 3, because 4 goes into 12 and 4 goes into 52. Okay, I just want to stop there and show you another method. So you could keep going now, and you could clean out this top corner, so you eventually have 1 tells you an x value, 1y, and you get an answer, and of course z is -13/3. You can also use back substitution at this point. So this, don't forget what this line says. This says 1y minus 3z equals 11. So if you really just want to get this y right here by itself, it would be 11 plus 3z. So just move this 3 to the other side, and don't forget there really are letters attached. So there really is a z there. So that's what I did here in blue. So it's 11 plus 3z. Sometimes it's quicker once you get it to this stage, or once you know one variable, just to stop and substitute. So I know that z is -13 over 3, and these 3's cancel out really nicely. So it's 11 minus 13, which is -2. And now that I know y and z, you could do the same thing with the top row. So this is x plus y plus 2z equals -3, or if you want to get the x by itself, it would be 1x equals -3, and then I'm just going to move this over, so that would be minus a y, so minus 1y, and move this over, so minus 2z. So this is a little bit of more like elimination, where once you find one letter, you sub it back into the equation and find the other variables. So again, y is -2 minus 2 times z, which was -13 over 3. So this is kind of a combination. So I'm not taking the matrix all the way to the perfect stepping, or to the perfect row reduction. I'm kind of just stopping it partway through, and once I find one variable, I'm subbing it back in and finding the rest of them. So what is this? Negative 3 plus 2 plus 26 over 3, which is negative 1, so negative 3 over 3 plus 26 over 3 is 23 over 3. And so just like before, we found an answer for x, y, and z. So there's x, there's y, and there's z. And of course, again, if you go back to the original question, the question was 3 planes. And again, we didn't really ask the question, but we're going to in the next section anyways. The question would have been, describe the intersection of these 3 planes. So those 3 planes cross at the point 23 thirds, comma, negative 2, comma, negative 13 thirds. Just like 2 walls and the floor cross at a point. I mean, really, when you draw 2 walls on the floor, it kind of looks like they cross at 0, 0, 0, right? You know what I mean? Just because of the way we draw them. Yeah. Anyways, so your 3 planes cross. There are some other ones that you can try, and these all cross in a point. So I will tell you the answer to this one if you want to try it. If you don't want to do any homework, just do this question. I think I won't give you any homework. So the answer to that question is 2, 3, 4. And again, you could do it very differently than somebody else does it. And there might be another one. I'm just making sure it's the same question I have. And I believe the solution to this one is 27 over 4, negative 15 over 4, and negative 25 over 4. So these ones, I mean, you're going to have to deal with fractions. So whether you reduce it the entire way or whether you reduce it part way and then decide to use back substitution, that's fine. But you should definitely try to clear out that bottom corner. And for this one, I would say I would write this equation first because I like that 1 right there. So my first line would be 1, negative 3, 4, negative 7 when you put it on the other side. And then I guess I could put this one next and then that one. So feel free to put whatever equation you like, maybe probably the one that has a 1 right there in the top row. So I wouldn't do any homework. If you could reduce those two, then that would be just fine.